back to the tutorial for deep learning. Today I'm going to continue with the fruit image classification using CNN and Google Colab part number 2. I want to thank for the medium.com. And previous session I explained about what is image classification and what is the role of image classification and what is deep learning 2 and CNN convolutional neural network. Just to give a recap, because convolutional neural network is one of the model where consists of a convolution layer, pooling layer, followed by fully connected layer and relay activation also. So last class we seen up to the visualize the image. I go for recap, then go for the one. So for this one, step number 1, we are importing the packages with the help of import OS and import pandas and the necessary files we are giving, and we are using and so on. Then we are going to fetch the data set from the Goggle with the help of this one coding, where after one we can go for the selection. We are following the data set. The name of the data set called fruits 360. So after that one, write the coding for mount to the drive. Once mount the drive, you can import everything to your drive and display the information whatever the files is there like that. Then print the information and the image look like. So set the training path, display the single image with the size of 100,100. That is the target size is 100,100. If you want, you can change it 200,200 also, and we can use the help of plot.show, and we can write a print of x.shape also. Is showing the sample of apple here. And how do we explore more image in the data set? If you want to visualize more images, we can write the code called visualizing the more images. We can write images equal to orange, banana, followed by walnut and so on. Then we can set the figure size as here 10,5 and follow. Then target size we can give 100,100. So if you give this and execute the code, it display the images like the images orange, banana, followed by watermelon and so on, walnut too. Then how to find the frequent fruit? If you want frequent fruit, you can write the code called fruits of empty array, then fruits image of array, then follow and find the topmost fruit. You can write new data followed by frequent fruits and write like this. So if you go this like it will direct and print the topmost used fruits in the list, that is grape followed by walnut at last. Then how do you print the total number of classes? If you want to print the total number of classes, you can write the code called class name is equal to global of train path plus then print the number of class, then output display 131. That is the total number of classes. What are the fruits? Everything come under the category of this category only, this number of classes only. Then create a model. So if you want to create a model, you have to display the input size. You have to mention the output input size, that is 100,3 by normal. Then we can use the max pooling for 2D support. Then we can use the plot and dropout layer and softmax, and we can write the model summary. Very important. For write the code, we can write model of sequential followed by model that add of flatten and activation. At last finish with the, we have to compile the model with the help of the matrix called RMS. Optimizer is RMS prop and matrix is accuracy. Because once go for the model, we can train and even machine learning or deep learning, we have to predict the accuracy, that loss also. If at a loss is less, we can say the model is success with the help of data set and implementing this coding here. Then write the output. It display the output like this: total number of parameters and base and internet speed, and we have to specify the epochs and batch size, where writing the epochs 100 and batch size 64, and argument data. So here argument data is in the sense what are the images there, we are making the form input size. After that we have to maximize or we can extract the images. So if we extract and if we extract and maximize, it will go for better visualization. That is called augmented data. That means whatever data we are going to visualize with a clear picture. So we are create the object with the help of image data generator, where it is specify the parameter 2, and we can with the help of augmentation we can do rotate the image, zoom the image, and rescale the image also. So we can do the code called creating an object for image data setter, data generator, followed by range, zoom range, and batches of argument data like directory, target size, and color mode RGB, class mode categorical. At last end with the class mode of categorical, and output. So if you give this, like it displays output like you found 67,000 something belongs to the 131 classes, another 20,000 belong to the another 131 classes. Now fitting the model, very so if you want to fit the model, With the help of augmented images, we can go for the code called it's equal to model.fit generator of, then followed by validation data and validate step 2. Then plot the loss. So if you want to plot the loss, you can write the code called plot of figure and legend and show. If you give it like this, it will display the model loss, and with the help of dark red, where you can train loss and validation dot. The graph displaying and accuracy. If you want to plot the accuracy, so you can go for the code called plot dot figure and history dot history, because we already trained them, and legend and show. Once give this, it display the model accuracy. So it is like this. And if you want to take a single image for prediction, you can write the code called display the selected image, where you can give the load coding path, that is load image of test path plus raspberry 77 underscore 100.jpg, where target size we are fixing 100. Then we can write the filter show for display, and we can load the image. If you want to load the image, you can write the function called definition space load of file name. Then we can write np underscore, that is numpy array, that is mp underscore image of image that open space, so open the file name, and we can give the information. At last we can load from the dataset called full 360, where the file name is, where the image name is called file or image name is called raspberry slash 77 underscore 100.jpg. So if you give this like this, it will predict the image and display like this. And image, if you want to predict the image class, we can write the code called prediction of np.argument. We are writing the print of prediction, that is it's saying it is belongs to the 113 class, like that. And class name, if you want a class name, you can write the code called test generator of dot class underscore indices. Then we can display information of pomegranate how much means 105, and similarly raspberry is 113, and tomato 1 class belongs to 120 class, and tomato belongs to 121, and so on. So this is the way how we can train the CNN model for the Google for fruit image classification, and at last we predict whether a fruit is a apple, orange, or anything like that. If you like the video, please subscribe and share with your friends. Thank you for watching the video. Thank you.